A transformer is a device that generates a magnetic field in the form of an electromagnet and induces current in the form of an inductor. Both of these devices are combined into one device, which allows the potential difference between magnet and inductor to be changed. A transformer consists of two coils of wire, the primary coil and the secondary coil. These coils can take as many loops of wire as is necessary. It is the ratio of the number of loops on the coils that allow a transformer to change the potential difference from one loop to another. The primary coil in a transformer has a current supplied to it. This current generates a magnetic field. The more loops on the primary coil, the stronger the magnetic field. The secondary coil in a transformer contains loops of wire which cut the magnetic field lines of the primary coil, and so induce an electromotive force, and therefore a current. The more coils the secondary coil has, the greater the current that can be induced. A soft iron core is placed in between the loops of the primary and secondary coils and connected together to increase the density of magnetic field lines and so increase the effect of both magnetic and induction effects. However, there is one major problem with the transformer, as it is described so far. In order to make a current in the secondary coil, you need to have the coil move relative to the magnetic field. If we supply the primary coil with a constant direct current, then we generate a stationary magnetic field and so won't make a current in the second coil. That's why transformers only work when supplied with an alternating AC current. The alternating current in the primary coil makes a magnetic field which increases to a maximum and then decreases to a minimum and then increases again, etc. This is a moving magnetic field. The magnetic field lines pass over the secondary coil and induce a current every time the loops on the coil pass through a field line of the moving magnetic field. If we have more loops on the primary coil, then we will generate a stronger magnetic field, and so more field lines. However, if we don't have as many loops on the secondary coil, then there won't be as many wires to cut the magnetic field lines. The potential difference supplied to the primary coil will be reduced on the secondary coil because there aren't enough loops to pick up all the magnetic field lines. This reduces the potential difference across the transformer. If there are the same number of loops on both coils, then the potential difference between the primary and secondary coil will be the same. If there are more loops on the secondary coil than the primary, then a potential difference will be increased across the transformer, as each field line from the primary coil is cut more than once by a loop in the secondary coil. The equation that shows this relationship is simple. The ratio of loops on the primary and secondary coil is equal to the ratio of potential differences on the primary and secondary coil. Ns divided by Np is equal to Vs divided by Vp, where S means secondary and P means primary.